Hello everyone, my name is Robert Pitt. I work at Park IT, building our new cloud platform for airport parking. Today I'm going to do a little bit of a talk around GraphQL. We've been using GraphQL for around about 2 years now, since the inception of the new cloud platform. Used it from the get-go, so I've got a little bit of experience with it. I've been engineering, developing around 14 years. Around 9 years of that was since the very first inception of JavaScript, of Node.js, when Ryan Dahl released it. I've got a passion for really simple, beautiful, elegant solutions. I worked for Google back in 2010, 2011 remotely, building some cool stuff for Google Hangouts when it was very first released. And this is my very first talk ever, so if I mess it up, bear with me. So what is GraphQL? So GraphQL is a query language designed to build client applications. It provides an intuitive and flexible type system that allows you to define your data models within your graph, and properties within those objects. It's declarative, so you don't have to write code in order to define something. It's hierarchical. You can have kind of a recursive tree of data structures and recursive references. It's a strongly typed system, so you define a property as a string. GraphQL will give you validation to make sure that that string is an actual string on the input and an actual string on the output as well. You can introspect it, so very much like RPC procedures in microservices, you can make a request to the GraphQL server and pull back its capabilities. And Facebook have designed GraphQL to be very product-centric. So you have to think of this not from the server down to the client, more from the client's requirements through up to the server and the microservices. So just to bring you into GraphQL, I'm going to go through a few areas. The first is queries and how to perform a query. So GraphQL, as well as a type language, it's also like a hybrid query language as well, using the same type system. So you can provide queries in a JSON-like syntax that will return you results that follows that structure, that's that pattern and that depth, and that hierarchical pattern, very similar with a response. So how do you define a schema? So in order to define a schema, you've got to define your types. And the GraphQL has some built-in types such as mutation and query, and these are what are called root operations. These allow you to be able to set a property on a root type, and then that property that you set is exposed to the client, so kind of like defining an RPC procedure. Within these individual properties within a type, you can specify what type they are as well. So you can specify whether they're a primitive type such as a string or an integer, a boolean, or you can specify a different type of object that contains sub-properties, and so on. So in this example, I've got a query, I've got a mutation. In GraphQL, mutations are basically queries, but that affect data and update data in some way, and change the values of the properties within that data. And when you define your GraphQL schema, you need to define a way for that schema to kind of be able to resolve that data from some back-end storage. And the way that this is done in GraphQL is we write resolvers. And resolvers are like a hierarchical object where the leaf nodes are the resolver functions, and these functions are executed whenever a GraphQL query is requested and a particular property in there is also required. As that gets executed on the GraphQL, it will traverse your query requirements and go over to your resolver map and automatically execute each resolver with the context and the meta information for that request, any arguments, and then it's that resolver's responsibility to take that input and to go out to the back end, fetch the data and return it back to the GraphQL system in the same structure as what your type definition is. And you can see in this example here, you can have a context. So for example, every single query that comes into GraphQL, you can instantiate this context which contains the user information. and that gets injected into your resolvers. So your resolvers then can have models that are very request centric. And you can then just call like get booking by ID, for example, but that model will know the context and know whether that user has permission, etc. Who's used directives before? In fact, before that, who's used GraphQL? Who uses GraphQL in production? Sweet. Who's used directives in production? One. Okay. So directives, they are sugar for your GraphQL graph. And what they allow you to do is allow you to put a tag on a particular part of the graph and be able to have alternative runtime execution around that piece of information. So these are really powerful for things like authentication, permission checks, if you want to transform that data into another type without having to understand the domain knowledge of the information, of the data. So in this example, I've just created two, scope and cache, right? And scope will run on every single, it'll run on every single node that you apply it to. So in this example here, I'm saying that this property needs this alternative runtime execution, which is called scope. And then these are arguments that you can pass in. All right, so this is a function that gets executed. If you think of it like an express middleware for an individual property, you can have the resolver injected in. You can wrap the resolver, run it, cache it, do lots of awesome things with directives. And there's another example here, which is a cache. So you can imagine that when something gets executed on your graph and someone requires a node that returns a booking, every time them individual bookings get instantiated, this cache will run before and you can wrap so you can execute after as well. So that if you've got like a global unique ID system, then you can implement caching on any node that follows that GUID kind of principle and have like a cache that you just define within a declarative way on your graph. So in order to define a directive, the first thing you've got to do is you've got to declare it, which is the top two lines, and you declare its possibilities or its functionality. So you can see here, the scope declaration has an argument of scopes that is an array of string, and the array must always exist, but it can be empty. And you can see that by the exclamation mark, which means it's required. So in order to code, in order to wrap this into code, you declare your directive, and in the declaration, this class, you can specify multiple different areas of the graph where you can apply your your directive. So you can imagine you've got a directive, you can apply it on an individual node, you can apply it on a type, you can apply it on a query, or particularly a mutation. And depending where you apply that declaration, you will have to define a visitor. In this example, I've just got a field visitor, but you can have a node, a type visitor, a union visitor for union types and other different sorts of graph implementations. And in this example here, all I'm doing is I'm wrapping the resolve, very much like a middleware for Express. I wrap the resolve, and then I can perform some alternative runtime execution before that resolve is actually executed. So it's really good for reducing the amount of code that you have in your code base and the complexity, and kind of centralizing the authentication into one function and just being able to apply it wherever you need it, rather than writing code in every single resolver. So here's some examples of the ways that I've seen directives being used in the open source community. The first one, generating resolvers. So you don't even have to declare a resolver. You can apply a directive that declares that resolver for you. So you can automatically declare a connection to a REST endpoint within the graph itself without having to define any code whatsoever. Some other examples, internationalization. If you want to format data, convert it to uppercase, lowercase, round it, things like that, you can write a directive, apply it straight to your graph, and any data that transfers through out to the client or in as a mutation, you can apply these to run there as well. Introspective is very important as well for GraphQL microservices. Very similar to RPC, we need a way to be able to communicate with a service and discover what its capabilities are. And the way that GraphQL do this is to do it with introspection. And what introspection is, it's an area of the type system that is able to describe itself, if that makes any sense. So when you declare a type system in GraphQL, it will automatically create a queryable area in which you can ask for information about the definition of this graph. In this example here, I'm asking a GraphQL server, your type booking, I want to know the name of it. Funny enough, we already know. But I also want to know the fields that that type supplies and the name of each one of those fields. This is also expands out to directives and any other form of information that you declare in your graph. So for example, talking about directives, you can apply a directive so it's declared on the server, it's exposed via introspection to the client. There's no functionality on the client, but you can have the client then use that directive with a query that goes back to the server. And the server then can see that that directive's been applied and can apply some alternative runtime execution based on the client's request. So who's done schema stitching before? Awesome. Nobody. So schema stitching is the idea of taking a graph, so we'll call it graph A, and another graph, graph B, and being able to convert them into like a syntax tree or an abstract syntax tree or like a JSON kind of object that defines that schema that you've got and merges them together, so you can combine types, you can merge queries, and you can merge types together, merge different properties from two different sources. And this is how that works. So here I've got graph A and graph B. You can pull in a few utils from GraphQL tools. You can pull in your separate individual schemas, you can merge them together, and out pops a schema that is the combination of those two, which seems really, really powerful for a microservice kind of platform. If you've got microservice A, microservice B, and you want a gateway or an API that's comprised of them two, but you don't want to have to, everything you implement on the microservice, you have to go to the API and then code to declare it and allow it to go external. You can stitch them together and have the microservice declare that functionality there. So local stitching, which what I just explained, is taking two GraphQL definitions that you've got in your current project, merging them together. So it's really helpful for if you've got a large singular project and you want to break it out into different types and different resolver sets. So it's easily manageable. You can do that. But moving on from that is you have this introspection, which means that you can talk to a service and another service and find out their entire graph and their entire functionality. So you can take that local schema stitching and do it over HTTP, and now you can pull schemas of two microservices together and merge them together into a single unified graph. And this works very similarly. We create a link to the remote service, and that's just a HTTP link with some caching modules in the middle of it. And then you can make an executable schema, which is the combination of a link and an introspection result. And what that allows you to do is when you combine these two schemas, if you pass the link, whatever link was passed with schema A and whatever link was passed with schema B, as you get your uniformed graph, you'll be able to query that graph, and GraphQL automatically knows what link to use to propagate that request out to the backend service. So you can have I'll get onto it, but you can have a graph that is comprised of two schemas, two separate microservices, and you do not have to worry about writing individual resolvers for all those fields to delegate it out to that service. It just does it for you. So schema delegation. So if you've got graph A and you've got graph B and them two merge together, so you've got a type booking and a type flight, and what you want to do is on your API you want to say this booking has a flight, but you don't want to have the booking service or the booking microservice know about the flight service, and you don't want to confuse the bookings data model with a flights data model. You want to keep them completely separate and isolated and in with a microservice fashion. So what you can do is when you merge them together, you can merge them with a third schema, which is your own API schema, and you can say this schema, it adds a property to the booking called float, which references the float type. Now you've already merged your booking schema and your float schema, so those types are available. So when your third schema has applied on the combination of them two, you can extend it to build references between each service. And then in order to, because that's a brand new property, in order to resolve some data, you've got to tell the graph where to go for it, because it doesn't have a link, so it doesn't know where to go for that data. So the way that we do this in schema delegation is that you have this fourth property in your resolver, and you can delegate that request or that part of that graph request to a sub-schema or a sub-server or a sub-microservice. And you can see here what we're doing is the individual introspected schema is being passed in with the context. And then what we're saying is we want to resolve this client property on the booking by delegating whatever the client's requested, whatever properties the client's requested, we want to delegate it down to that service. So you're just handing it off. And then the response comes back, and this server already knows about client's information. So because the client's already been stitched in, that the data that comes back will be valid against your graph, because you've stitched the client schema, and then you delegate a request down, the response back will match that client schema specification. And yeah, you can pass arguments, and then you can forward context and trace context along with it. Okay, so distributed data graph, GraphQL Microservices. So the benefits of doing GraphQL Microservices is that it's distributed. Your data, this is very, very much like what we do right now with microservices. Your data is kind of siloed into its domains and where it needs to be, and there's a reduced conflict on information sharing between those. So you want to keep them distributed and isolated from each other. GraphQL allows for that. You want it to be scalable, very similar to going from 5 instances of a microservice through to 100 instances of a microservice. It's not going to make a difference because it's just a HTTP API. You can scale it however you like. It's the GraphQL language agnostic. So for example, if we've got some high intensity machine learning systems and you want to be able to provide an API interface into that, but it's written in Python, well, you've got the API which is written in Node.js, and how do you merge them two together? Well, this is just HTTP and individual schemas. So it's completely agnostic. You can merge a Node.js server with a Python server, with a C# server, however you like. It's all about the interface. It's all about the protocol. You can introspect it. It's composable, as we just discussed. You can have multiple schemas merged into one. They're independent from each other, so the booking service doesn't need to know about the flight service and doesn't need to know about the client service, etc. And it's modular as well, so you can take these things like directives and you can reuse them across different microservices. So you can have an authentication directive, which is its own individual NPM library, and then all your microservices import that one directive, and that way you're going to get a consistent authentication approach to across your microservices. And if you want to improve performance, that's centralized then as well. So if you've got a caching directive that you use, you can improve the performance of how that works separately to all the microservices. So I want to give a little demo today. It's not a big demo, but I'm sure you'll be able to understand how this would work within your own projects. So let me just jump into a little snippet of code. So I've just got this wrapper framework, it's an Express framework that starts up 4 individual HTTP microservices. And these microservices are obviously GraphQL. I've got a gateway, I've got a site, I've got a flight, and I've got a booking. Now, the booking, the flight, and the site would be individual isolated microservices. They don't know about each other, they don't conflict in their types. They're completely separate databases and separate type definitions. And I can just show you what that looks like now. So again, you pull in your schema definition and you register your resolvers. And that's all that's required in order to create a GraphQL service. And it's exactly the same for the flight service. You can see here, we just got some mock data. We've got a resolver to query that mock data, and we've got our schema definition. So in this schema definition, I'm defining an input filter type, I'm defining a flight and a status enum, and I'm defining a route operation, which means that in order to access the graph, you have to go through a route operation first, which is like the top level of your graph. And then once you go into that, you can then hop between different types of nodes. And then we've also got a gateway service, and this comes back to the remote schema stitching. Is if we've got microservices that are running GraphQL servers, and we want a gateway, we want a single API that pulls all that together and provides it out to the client, we can do that with remote schema stitching. So I've got a little project that I'm playing with called Vertex, and it's just a util library around creating GraphQL services. And you can see here what I'm doing is I'm creating 3 remote schemas, and all this function does is create a link to that remote service and then introspect it and return the both. And then what we do is, if I switch, so here is the site service. So you can see I can query the first site, Birmingham short run, query the second site, meet and greet, and that's all that site API is. It's just one method, one route operation, and a couple of types, and it only knows about its own data. We've got the same for the flight service. So you can see here I've got first flight just landed. I've got a second flight which is on time. Third service is the booking service, and I mean if we just take a quick look in here, there's nothing in here about flights. If I look at an individual booking, there's nothing in there about flight either. There's nothing in there about client or site, because the booking service just knows about the booking information. That's it. But we need to bring them together. We need to be able to allow our client to jump from the booking to the booking's flight information. And what I've got here is this is that gateway service that I've just mentioned and just showed. It's introspected the 3 different individual schemas, merged them together, and provided one single unified API. And now if I have a look at the schema, you can see the schema is comprised of the combination of all of those services. So you can see that now on this gateway service, we've got a flight, we've got a get site, also the mutations as well. I haven't got it here because I haven't written on mutations for the site or the client, but mutations are forwarded as well, and directives are also introspected and brought forward as well. So a directive that you apply on a microservice, you can have that directive code on the gateway, and whatever goes in and out the gateway will be executed there and then, rather than being delegated down and letting the error come from the service back up to the top of the API. You can just bring that validation library to the API as well and get it consistently validated on either the API or the service level. So just to give you an example, so if I get a list of bookings that are pre-check-in, for example, you can see now the booking has some extra information that it didn't have in the booking service. It has the site ID, it has the flight information, and it also has a site reference. So if I pull back that, for example, what has happened now is the request that I've sent to the gateway has been delegated on to the microservice. The microservice has received that request, executed it, and delegated the result back upstream to the API. But on the API, we have defined some extra information in the schema. So you can see here now, this is the 3rd layer of this schema stitching approach. So you can see here that what we're doing is, because we've already stitched the booking service together and the client service together, what we're saying now is we want to extend a particular type, and we're extending the booking schema, and we're adding a property called flight that references a flight type. But this is the flight service, which is completely isolated and separate as well. And we're also extending the site object, which gets introspected from the site service and provides a link to bookings. And then once you've defined that extension of your schema, you can then move on to the delegation. So here, as you can see, when someone fetches a booking, for each booking, every time that flight's requested, it will execute this resolver. This fragment will specify what data that resolver requires from the backend service, regardless whether the users requested that information. That information you're declaring is needed here in this resolver in order to hop across to that flight node. So you declare your requirements for the data, and then you delegate that out to whatever service it needs to be delegated to. So we've got one checked in booking, but now what I can do is I can come across to the site and I can get the site information for that booking. Yep. If I was to look at another booking, probably not that one. Yeah, so that other booking. So there's an ID on the booking which is called site ID. And whenever someone requests the site object, we request from the booking service, I need the site ID with whatever other properties that users required. Once you've got that site ID and it comes to the site resolver, you can take that ID and then delegate that to the site service and say, I need this site in particular. So this is GraphQL schema stitching. This principle is probably about a year old. We've moved on a little bit, but there's a project out there called Apollo Federation. I don't know if anyone's heard of it yet. But Apollo Federation is Apollo's kind of specification to how schema stitching should be done at scale. Yeah, and if you just Google Apollo Federation, the articles on there are absolutely amazing in understanding how this works. When you've got 1,000 microservices and you've scaled 100 different types of systems. They take a different approach. Instead of the API extending the individual types that are coming back from the services, they've got a bunch of directives that allow you to declare that on the service level, and then what you're doing is you're federating that up to the API level. So your service says, I can join with service A or service B, and I can add these types if it's available, and the gateway will put all that together for you so you can work on an individual microservice. Back. Okay, thank you. Any questions? Sure.
Does when you stitch together two microservices, do the call microservice, like if you call a remote microservice, does that know that it's been called through a gateway?
Yeah, so we talked about this thing called context.
Can you repeat the questions for people online?
And for everyone else, because
Yeah, sure. Sorry, 1 second. Yeah, so you have a context which you can instantiate when you receive a request, and you can pass that context on with the delegation. So similar to how the RPC context work, where you can kind of trace the hops between the different microservice that the request goes through. You can do the exact same thing with GraphQL, so you can see what request it come from and where's it going back to and where you need to forward it on. So yeah, you can use the context for that.
Okay.
Questions online? Anything? Yeah.
What's your favourite thing about GraphQL?
Just the type definition, really, the language, being able to describe your data set without having to write code, I think is probably one of the most interesting things. I know that a lot of people in the community kind of humming and ahhing whether you should go to schema definition language or you should define it in code. Personally, I think everyone should be writing schema definition, and any intricate areas that you can't do with the schema definition language, you can always write it in code and then merge them two together in a very similar way. Cool. Yeah.
Are there any tools around or in GraphQL that would allow you to have a good look on the all your microservices and how they're connected or something like that?
Yeah, so in terms of performance, if you wanna like have traceability, there's Apollo does some great tools. I'd really recommend people look at Apollo. They've got a service that you can connect into, and all the tracing goes into that. In terms of being able to visualize your graph entirely, again, schema stitching is a great way to do that. We already have tools like GraphQL Playground. So if you've got 10 microservices and you wanted an overall view of it, you can stitch them all together in like a temp API and just look at it. And there's also online tools that allow you to turn those into actual graphs that you can actually, navigate through and organize like you would like a MySQL table specification. Yeah.
When you do the schema stitching, can you define like a dependency between them so that, so in your example we had a booking in a flight, if I presume that the flight service would have to have a local reference between this booking is this flight, or could you define that it would actually look up the booking first, come back, give it like some search parameters, and then...
So the way that we do things down at Park IT is that the booking service and each individual booking record will have an identifier to something. So a site, a client, a flight, or whatever. In the flight example, I'm actually just taking the flight date and the flight code from the booking object and sending those two to the flight service, which is able to resolve a flight for that. But in terms of like the site, for example, each booking would have a site ID, each booking would have like an integer-based ID, and then you'd use your schema delegation to know that that ID exists, and you can go get that information by calling this route operation on that service.
If you're doing something where a bit more dependent, like an availability or something like that, where you have to perform like a product type search first, come back, and then pass some more information to the flight service from those based on those products?
Yeah, so that's at the gateway level. So you fetch the booking, you delegate, you return the booking, and then you have all that information available. And then your second tier of request would go out to whatever second tier of the graph data is required. But you with that fragment as you see in the delegate resolver, you can specify the data that the resolver requires, not what the user requires or the client, but what the resolver requires from that service. So you can take that information and resolve some other data in some other service. Yeah. Yeah.
Can you opt out of exposing things that are on the query types of microservices that are behind you? Like if you only want to use them as like joins?
Create a directive called expose, which has a Boolean input argument, true or false, and then you write the code for that directive on your API, and anything that's false, you strip. So I don't know if you could quickly see, but in the directive, so you can see the argument that gets passed in is the GraphQL field itself, and you could easily just delete it and not expose it whatsoever, and strip it from the graph. And your directives that you define can be separate individual npm modules that are used both on the gateway and on a service. And then as long as the code's the same, the GraphQL request specification that gets passed along will re-execute at every point that resolve is defined and available. So if you've got a 3-tier kind of gateway service, you can have one directive that's defined through all three that run that validation check every time and consistently. Yep. Cool. Everything?
Yeah.
Brilliant. Thank you very much.